Good afternoon, everyone. Today, Andrew and I will be walking you through how to determine the equation of the polynomial in further form. By the end, you will see how root the d together to shape a polynomial graph. Let's begin with basis. You all want to know about the rest of the polynomial function. The polynomial function is look like this. In the polynomial function, we see the thing was mattermost. These are the degree. The degree is the highest exponent, the leading coefficient. In the polynomial function, the highest power is the leading coefficient, the zero of the root. The zero of the root means the value where the f of h equal to zero. These are not just a number, they is the entire shape of the graph. In the graph, we can see the polynomial function f of x equal to h minus 1, h plus 3, h minus 2. In the graph, we can see the x-intercept from the root. The y-intercept curve for substitution is equal to 0, and the degree with the leading coefficient determine the end behavior of whether the graph goes down, goes up, or both. The further forms is really powerful and important because it reveals the x-intercepts immediately. For example, we can see the polynomial function f of x equal to 2 into x minus 3 into x minus 2 into x minus 1. In this case, we instantly know the root of 3 minus 2 and 1. From this equation, we can also know about the multiplicity. The exponent of each further indicate the multiplicity. Multiplicity of 1 means the graph cross the axis at the intercept. The multiplicity of 2, the graph will be bounces and touch and turn around at the intercept. The multiplicity of 3, this means the graph cross with the inflection at the intercept. We also investigate about the key feature to identify the polynomial function. These are the x-intercepts, y-intercepts, and behavior, and also possible turning point. X-intercepts is directly obtained from the feather is a feather form. This point the graph cross the torch as the x-axis. The y-axis is always found by the substituting x equal to 0 in the equation. It's where the graph cross the y-intercept. The end behavior can be determined by the degree and the leading coefficient. The possible turning point also important in the function. The points where the graph change the direction, it goes as it goes down the polynomial or degree can have the most, and minus 1 is the turning point. These are the foundation we will use to actually build the polynomial equation. And now Andrew will walk you through the process.
So thank you so much, Julian, for the contribution. And my name is Andrew, and starting from now, I will continue the rest of our presentation. So I will start from constructing the equation. So to construct the equation, we have to identify the root, plot x-intercept and multiple CD, and determine and behavior, and then we have to find y-intercept, and we can sketch the graph and write our final equation. So how to identify root? To identify the root, we can identify the root by determining the x-intercept from the given information, just like a question of graph. So this will form your feather and plot x-intercept and multiple CD. To find it, we can find it by placing the x-intercept on the graph and note if the graph cross or bounce based on multiple CD, and then determine the end behavior. We can determine the end behavior based on the degree of the polynomial and the sign of leading coefficient. This will sketch the direction of the graph and then find the y-intercept. We can find the y-intercept by calculating by substituting the value in our given polynomial, and we have to sketch the graph. We can sketch the graph by using the x-intercept, multiple CD, and behavior, and tested value. and then we can write the polynomial equation. So we prepare we also prepare an example challenge. In our example, we have to determine the polynomial in a factor form with the root of x equal to -2, 1, 4, and passing through the point 0, 8. This problem gives us three critical pieces of information, which is x-intercept, root. We can also note it as a factor and one additional point that polynomial pass through. And also, this extra point is crucial for finding the leading coefficient, which is a. And now we'll solve the problem. As a first step, we'll write down our general equation, which is f of x equal to a x plus 2 into x minus 1 into x minus 4. And then we have to find the value of a, which is coefficient. To find the leading coefficient, we have to substitute the value in our equation. We have to substitute the value of a in the place of f of x and the value of 0 in every place of x. And then if we calculate, we'll get the answer a for our leading coefficient. So our equation will be f of x equal to x plus 2 into x minus 1 into x minus 4. In here, so which is x-intercept? X-intercept at -2, 1, 4. X-intercept is at -2, 1, 4. Since each factor has multiplicity of 1, the graph will cross at the x-intercept at this point. And the y-intercept, we use y-intercept. Uh, we we use the point 0, 8 to find a. This means that graph cross the y-intercept at y equal to 8. And by multiplying the h term from our factor -2, 1, and 4, we will see that the function is cubic with the degree 3. And the leading coefficient is 1, which is positive, so the degree is odd. The end behavior will be downward in the left side and the upward in the right side. So this is our graph. In this graph, it represents it representation confirm all the feature we derive. The curve cross the axis at -2, 1, and 4, and also it passes through the y-intercept at 0, 8, and also as x goes down to negative infinity, f of x goes down, and the x goes to positive infinity, f of x goes up. Oh, sorry. So in here we will see numeric and algebraic. So what is numeric? Numerator is a value. Um, we get those value by substituting in the equation, and we have to use this value to sketch the graph, and the algebraic is the equation. So as a summary, to warm up, further from given as direct access to the root, degree, and behavior, and also always confirm with a known point. And by connecting algebra, graph, and number, we fully understand polynomial behavior. So this is the end of our presentation. Thank you so much for your listening.